I'm Anil Kumar sharing with you questions from my subscriber who wants to understand how to sketch graph of a function from given conditions. So we have two questions here. We need to sketch graph of a function that has following properties. Question number 1, this is the set of properties, and for question number 2, we have these 4 properties. Let's look into them one by one. Question 1. First derivative is greater than 0 for x less than 1. Second derivative is also greater than 0 for x less than 1. And when x is greater than 1, then both these derivatives, first and second, are less than 0. That is your question number 1. Question number 2 is, there are relative extrema at -1, 7 and 3, 2. That means there could be a maxima or a minima. There is a point of inflection at 1, 4. Second derivative is less than 0 when x is less than 1. The x-intercept is -4 and y-intercept is 6. You can actually pause the video, solve, and then look into my suggestions. Now let's see how to solve. Now here, when I say that first derivative is greater than 1, it means greater than 0. Means what? It means the function is increasing. So this condition says that when we are talking about x less than 1, the function is increasing. And the second condition here, which says second derivative is greater than 0, it really means that's concave up. So when x is less than 1, function is increasing and is concave up. When x is greater than 1, in that case, first derivative being less than 0 means function is decreasing, right? And since the second derivative is negative, it is concave down. So that is the characteristics. Now based on this, we do get that first derivative analysis will tell us that we have maximum at x equals to 1, right? So it is increasing and then decreasing. And this condition tells that there is a point of inflection kind of, right? Change of concavity also at x equals to 1. Now how do we sketch such a graph? So let's try to make an attempt. So, okay, so let's try to do it. So what we have here is a function. Let us say this is 1, x equals to 1. Now on the left side, it is increasing and it is concave up. So basically, the characteristic is kind of like this, right? And on the right side, it is decreasing and is concave down. So it is kind of like this. You see that? So decreasing and concave down. So that becomes the characteristics. And you do see that here we have a maximum, correct? We have a maximum, right? So you could sketch a function like this. At 1, we are not given any condition whether the derivative is defined or not defined. We're not given any of those characteristics. So that should work, right? So that is how we will do it. So in this case, the function f of x will be like this, where at 1 we do have a maximum, right? So that's how it will be. Now let's look into the second condition. Now in this particular case, we are given points, right? So that much of flexibility is not there with us. So let's try to analyze. These points are at -1, 7, 3, 2, 1, 4. So more on the right side. So let's sketch it like this. Nothing negative. So okay, so let that be our coordinates. So what we are given here is that there is a point which could be maximum or minimum at -1, 7. Let's say this is -1 and this is 7. The other point is 3, 2. So at 3 we have a point, let's say this is 3, 2, right? So this is 3, this is minus 1, that's the point. There is a point of inflection at 1, 4, right? So 1 and 4, so this is point of inflection. So we're just marking the points at present. We are also given that x-intercept is at minus 4 and y-intercept is at 6. So somewhere here the graph can cross, that could be 6, and negative side is right there. So, well, that's very clear. And there is one more condition which is given to us, which is second derivative is less than 0, means negative, right? So when it says negative, then when x is less than 1, it is concave down. So that makes sense. So what we can do here is, this is our point of inflection, right? So we can sketch a graph which is kind of like this, making maximum here and coming downwards, right? And that is an extrema, so it could be a minimum, local minimum, right? So it could be a local minimum, so the graph could go like this. Now that satisfies all our conditions. We can write this point, which is y-intercept, as 6, right? So this is given to us as 6. So this is y-intercept of 6. That is the maximum, which is at minus 1, 7. Here we have a minimum. Let's say this is the minimum turning point, which is at 3, 2. This becomes the x-intercept at minus 4. And during this interval, that is 1 and 4, 1 and 4. This becomes the point of inflection. The concavity changes. Do you see that? So that is how you can actually sketch your function. So I hope the steps are clear and you can understand how from a given condition we could sketch. Well, these are not the unique graphs. You could have many different types of solutions. However, this meets all the criteria defined in our question number 2. So I hope you understand and appreciate what we have done here. Feel free to write your comments and share your views. If you like and subscribe my videos, that'd be great. Thank you and all the best.